So cesium-137 is a radioactive isotope which is found in used fuel rods from a nuclear fission. It is a beta emitter with a half-life of 30.2 years. We have to complete for beta emission, negative beta, like nucleon number does not change, proton number increases by 1, and for beta this will be 0 and -1. When it is removed from a fission reactor, a fuel rod contains 1.36 exponent 24 nuclei of a cesium. Calculate the activity of a rod due to the decay of a cesium 137 20 years after a removal from the reactor. And 1 year is having 3.15 exponent -7 seconds. So we need the total activity. Activity is like n lambda. You can, if you want to calculate an activity, it's equal to n times lambda. So first, like when it was removed, fuel rod contained 1.3 exponent 24 nuclei, and we calculate activity of a rod due to the decay of a cesium 20 years after a removal. So first, what we have to do, like when we remove, this was the original number of the nuclei present. We will find after 20 years how many nuclei will be there, and that will be equal to this n. And how to work out the lambda, the decay constant lambda is equals to 0.693 over half-life, so we can work out the lambda as well. So n is equals to n naught e raised to a minus lambda t. That's a formula which relate the number of the, like how many atoms have disintegrate, like left after a certain time interval, where n naught is the original number, 1.36 into 10 power 24, e raised to power minus lambda. How to work out lambda? So lambda is 0.693 over half-life. So 0.693 divided by half-life, that's equal to 30.2 years, but we have to convert into second. 3.15 into 10 power 7 second. Because activity, the time should be in second. It's how many atoms disintegrate per second. That's why whenever, if the question was not about activity, then I will not convert. I can work out how many atoms will be there after 20 years without converting a unit. But because we need an activity, so time should be in second. So this will give us a decay constant, which is 7.29 into 10 power minus 10 second inverse. So this one is 7.29 into 10 power minus 10 times, because we need after 20 years how many atoms are there. So this will be 20, but time should be in seconds. So we have to multiply by as 3.15 into 10 power minus 7. 3 not minus 7, 3.15 exponent 7th. So we multiply, this will give us how many atoms are left after 20 years. So this will be n, and after getting the n, like substituting this value, after getting the n, activity is equals to n lambda. So we have the lambda, we have n. This will give us activity which is about 6 exponent 14 becquerel. When a cesium-137 decays, also emit out gamma radiation. Explain why the emission of a gamma is more serious hazard than emission of a beta. You have to refers to the penetration power here, like gamma is more penetrating than beta. So we need greater shielding around the cesium to stop these gamma. So refers to penetration, gamma highly penetrating. As a result, we need a greater shield